Today we are going to discuss nuclear physics, topic number 3. Today is our third lecture. We are going to discuss the radioactivity. In radioactivity, first of all, we are going to discuss the detection of radioactivity. In core topics, first of all, we have to know what is meant by the background radiation and the sources that contribute in the background radiation. For example, radon gas, rocks and buildings, food and drinks, and cosmic rays. We are also going to discuss in core ionizing nuclear radiation that can be measured using a detector connected to a counter, and when we measure them in count per second or count per minute. In supplement, we are going to discuss the measurement of background radiation to determine a correct count rate. So let's start. First of all, we are going to discuss what is meant by background radiation. Weak radiation from the external sources which is always present. There are some sources in which produce radioactivities, but there are some sources which are external sources, and some radioactivities are always present in our atmosphere. These radiations are called background radiation. Radiation is energy that comes from a source that travels through the space at the speed of light. Radiation travel at the speed of light. Okay, in diagram you can see the radiations are coming from the sun. The radiations are from the indoor radon gas. Our bodies also radiating. Plants also radiate, and food we eat also radiate. And the radioactivity soils and rocks, these are the sources of radioactive background radiation. So, know the sources that make a significant contribution to background radiation. In background radiations, first of all, we are going to discuss the radon gas. Radon gas produce 50% of the background radiation. We can see from here that 50% of background radiation is produced by the radon gas, while cosmic rays from the sun or the stars are 10%, while food produce 12% of the background radiation. Ground, stones, the underground, different materials that are radioactive produce 14% of background radiation. And the medical instrument we use for the diagnosis of people also produce radioactive background radiation from the radioactive materials. So medical we use 14% of the background radiation. Okay, this is the overall chart in which we will see that the background radiations are due to the cosmic rays, radiation from the rocks underground, nuclear fallouts, or the medical rays, and the radon gas. Number 3. Know that the ionizing nuclear radiation can be measured using a detector, which include photographic film, ginger Muller tube, and cloud chamber. These are the three ways to detect the radiation and to count them. We are going to discuss photographic film. The photographic film is a piece of paper, which is initially white. When the radiation falls on it, it becomes darker. The more radiation falls, the more darker it gets. For example, when we take X-ray of anybody, this photographic film is of around white color, but when it hits by the X-rays, it becomes darker. And by hand or by the bones from our band, the radiations could not pass, so that's why this place is white. And except these, all the places become black because more radiation are absorbed at this part. The workers that work in the mines also use these radiation badges known as film badges to check out how much exposure they get from the radiations. So if there are high radiation, that mine is closed for the people, because the more radiation our body absorbs, it will be more harmful for us. That's why people work in mines get 3 months off after working for 3 months to radiate the radiations they have absorbed. The next one is the ginger Miller tube. A ginger Miller tube can detect radiation. How it can detect radiation? It consists of a metal tube in which there is a gas. When the radiation went into the chamber, it radiates, it gives its energy to the gas atoms, and atoms lose their outermost electrons. When these outermost electrons are loosed by the gas, the positive particle, the positive cations move toward the cathode, while the electron move toward the anode, and due to which a charge will start flowing through this circuit. There is a counter at this place. When it detects the flow of an electron, it count it as 1. Another electron comes, it count it as 2. Another electron comes, it count as 3. In this way, it counts the number of radiations that enter in the Ginger Miller tube. Each time it absorbs radiation, it transmits an electric pulse to the machine, which produces a clicking sound. The greater of the frequency of the clicks, the more radiations are present in the atmosphere. The third one is the cloud chamber. A cloud chamber is a small container which contains vapors. At the base we have a black metal base. Why we use black metal base, I will tell you in few seconds. There is saturated vapor inside here, and a source is also present inside the box. Here is a perfect slit to see inside the chamber for the seeing purpose. When this source radiates alpha, beta, or the gamma radiations, the alpha and the beta radiations can be seen by the cloud chambers. The alpha by the alpha source, it creates short broad tracks, while for the beta particle these are long wispy tracks. When an alpha particle passes from the gas or the vapors, it ionizes the vapor, and atom get excited and de-excited. In the de-excitation, it emit radiations. It emit radiation in the form of light, and you will see different color of lights over here. From these tracks, we can detect their radiations as alpha particles or as the beta particle. What are alpha, beta, and gamma? We will discuss it in our next lecture. These are the three types of radiations. The black base make us clear the image of the radiations. ब्लैक जो हमारी जो बेस होती है उसकी वजह से हमें साफ दिखाई देता है कि कौन सी रेडिएशन यहाँ पर क्या हुई है, एमिट हुई हैं. You can make this at home as well. Okay. What is the count rate? Count rate is the number of count per second. How many radiations are counted per second, or how many radiations counted per minute. These are the units for the measurement or the calculation of the radiation. Okay, use measurement of the background radiations to determine a corrected count rate. If we are using this chamber and there are some background radiation that are also entering in the chamber, then our detected result will not be as suitable as we want. So first of all, we will find out the background radiation, then calculate the total result and remove the background radiation from the our result. For example, the background radiations are 6 count per minute without placing the source inside the chamber, without source. But when we place the source, it is 36 count per minute. Now we will minus these 6 from our counted result. Then it means that 30 counts per minute is our result. The 6 here are the background radiation, and it should be subtracted from our final result. Background radiation has to be subtracted before attempting to perform calculation. Corrected count rate. Background radiation must be accounted for when taking readings in a laboratory. This can be done by taking reading with no radioactive source present and then subtracted this source from radioactive with the source present. This is known as the corrected count rate. Okay, our lecture ends here. Most of the question from here could be about the background radiations, how background radiation are measured, or what are the ways to measure, what are the ways to check the background radiation. We can detect the radiation with the help of photographic film, ginger Miller tube, and the cloud chamber. And what are the contributions of the background radiation? Background radiations are contributed by the radon gas 50%, cosmic rays 10%, food 10%, ground or the stones present, or the atom present, or the substances present, the radioactive substances below the surface of the earth. And for the medical treatment, we use these radiation for the medical treatment like X-ray. Okay, we will meet we will discuss the alpha, beta and gamma radiations in our next lecture. See you next time.